Hello, today is the 13th of November 2024. This is Hector Vladimir, and I'd like to discuss one more time the very exciting yet challenging and mystifying problem. It's a set of problems that we have for deep space missions. We have dreamed, we have hoped, wished for many, many decades on going to the moon, other planets, Venus, Mars, Mercury, Jupiter, Saturn, and even Pluto. We have dreamed about those trips to deep space. Many scientists have planned and postulated and even demonstrated the viability of such trips, such as Wernher von Braun in the 1950s, 60s. He wrote a book called Das Mars Project, and there he very scientifically and viably laid out a plan to go to Mars. It was quite ambitious. It required, I believe, multiple spacecraft that were huge, and the scale of the project, of the mission, was vast and grandiose. Something that, if even possible with today's economy, climate, and willpower, it would require an entire globe, the collection of nations coming united or uniting in such endeavor. Something that is hardly even feasible right now with the way the political environment is right now, with war and conflict all over the globe. However, many other people, Konstantin Tucholsky, Johannes Kepler, and many other ancient scientists and scholars dreamed of going to Mars. Many modern, not so much scholars, but business people like Jeff Bezos, the clown Elon Musk, and some serious and very educated scientists such as Robert Zubrin have postulated and advocated for trips to Mars. However, no serious plans have been laid out, approved, have been developed, have been shown to be viable. Not by any of these people, companies, or even space agencies. They still do not have a demonstrably viable plan to go to a planet like Mars. The trip is just, as of right now, impossible to make. That is one main reason why it has not come to fruition, has not materialized, I believe. These plans to go to Mars and beyond, and even the moon, remain just that: plans, dreams, wishes, hopes. And partly that's why I believe there is a lot of doubt about the past trips to the moon, because of this reluctance and inability, seemingly, to routinely perform trips to outer space, that is, beyond the moon orbit. Many say that robotic missions can do the same job as people. There is really not a need. With some validity, many people say that there's not a need for humans to go beyond low Earth orbit, and that robots can much easily and a lot easier and cheaper and more simply go to outer space and perform whatever tasks a human would do in outer space. Which, by the way, they are humans, the ones that are building these missions, planning these missions, and going on these missions. It's just that they are performing those remotely. Those are not automated or autonomous robots that go on these missions. These are robots completely controlled by humans on Earth. So make no mistake that these missions are robotic. They are human. It's just that they are remotely operated and they are virtually operated by humans. But these, again, deep space missions are just a dream because mainly there are many problems, many issues, many hurdles that we are yet to surpass, yet to solve. These are and remain unsolved problems for human spaceflight to deep space. And NASA, the National Aeronautics and Space Administration, has organized these problems into 5 broad categories. They are the problem of radiation, isolation, distance from Earth, gravity, and enclosed and hostile environments. These are 5 broad areas. And I want to discuss each one of those areas, each one of those categories, problems, issues that have not been solved, in a more of a layman's viewpoint, layman's attitude or commentary on those. In other words, how a layman like myself would view such problems for space exploration, and how a layman like myself would go about trying to offset these problems, if solving and offsetting these problems is even possible. The many space agencies believe that they are problems that may be solved, that are being worked on actively right now, and they are problems to be surpassed and conquered. That's what these space agencies and many of the scientists, specialists, and even businessmen believe that are involved in these endeavors to conquer these sometimes seemingly unsurmountable problems. So we'll start with radiation. Radiation, of course, is a huge problem, is perhaps the most pressing and severe problem as seen by NASA and perhaps many other space agencies and experts. Radiation, of course, as many of you may know, affects the body adversely. I mean radiation from space. Of course, we get bombarded with low levels of radiation or low energy radiation from all over the place, including electromagnetic waves, radio frequency waves, some forms of microwave sometimes, some forms of RF, again radio frequency waves from cell phone towers and cell phones themselves, other equipment. All this radiation is bouncing all over the place in our modern world. Of course, we are getting bombarded with those constantly. However, those are relatively low energy fields, forces, waves that our bodies don't react negatively to. For the most part, of course, many may argue that they do affect your health, and they may, some of them, many of them, over the long run. However, exposure levels are relatively low for most people, and they are relatively of low harm, let's call it that. However, in space, once you get out of the Earth's atmosphere, a couple of miles above from the Earth's surface, you are suddenly exposed to cosmic radiation. Cosmic radiation is and will be high energy radiation coming from different sources. One of them is the sun, as solar wind, solar storms, coronal mass ejections, CMEs, I believe they're called. Also, radiation comes from stars, supernova, quasars, and black holes. Those are particularly strong in space. And when I say radiation of high energy, I mean ionizing radiation, meaning that there are particles flying through space, constantly raining down everywhere, with almost no exception, that are made of heavy metal particles or heavy atoms. And these are, of course, in their atomic scale, they are the atoms of these heavy elements, such as titanium, gold, silver, such as all of the elements in the table of elements. You pick one and they are flying around in space, being shot at you and everyone else that may be around in space for whatever reason. And they are flying around at almost the speed of light. I mean, these particles are zipping through pretty damn fast, and they destroy DNA and any other living cell as they impact these cells. And many a times the body, these cells are not able to repair themselves, and they may become cancerous. There's a very high chance that these cells may become cancerous, and there may be DNA damage. And that is obviously not a good thing for any living organism. That is a huge problem. High energy radiation starts from even before, at high altitudes, even before you cross the line to space. And it gets worse as you get out of the Earth's magnetic field. Of course, as you go through the magnetic field called the Van Allen belt from Earth, there are a concentration, layers of concentrations of these particles that are trapped in the magnetic field from Earth, perhaps other heavenly bodies. So going through these magnetic fields, if we venture to go through these fields at all, of course we would have to go through it. If we get out of the Earth's magnetic field, we have to go through it because we live in it, inside of it. And of course these magnetic fields are at very high altitudes. They are perhaps hundreds of miles above the surface of the Earth. I forget the exact distance. It may be a lot more than that. I will update this chat with the correct figure. Earth's Van Allen belts are 1,000 to 12,000 kilometers above the Earth's surface. But of course, we have to travel through it to get out of Earth and go to deep space, other places such as Mars, the Moon, etc. So, long story short, radiation is harmful. It could cause cancer. It could cause all kinds of debilitating diseases. It could affect all kinds of vital organs, their functions, because these particles are constantly raining down on your organs, on your body. They go through your body without you even noticing, and it is constant. And they come in higher concentration, of course, when there are perhaps waves of events that occur, such as waves of high energy particles from a, let's say, supernova explosion that happens to pass through your area of travel as you go through, or if you are in the solar system, the solar storms, which are high concentrations of solar particles that are propelled by, of course, the magnetic fields of the sun, which are quite strong. So radiation, again, a big problem. Shielding is the primary way for us to be protected against radiation. Of course, you want to block those particles from piercing your body in the first place. You have to have very heavy elements blocking those particles, such as lead. You would need a lot of water around you, contained in some sort of tank. That's also a good deflector or filter for a lot of the radiation. I'm not sure if it's for all of it, but perhaps a good portion of it could be blocked by water. Also, human waste, defecation, or shit could be used to block at least some of the radiation. And there are many other materials, compounds that are effective for the radiation raining down from space. So that is a challenge. We are yet to come up with the technology, the rocket power, the propulsion to blast off these heavy materials, heavy supplies, heavy compounds, like large amounts of water. We are limited as of right now with the amount of materials, with the amount of supplies that would be needed. We are limited by our propulsion systems of today. Our rockets can only lift a certain amount of payload. As of right now, the maximum payload is something that I'm going to include here in this chat, update you with that, what the maximum amount is. But I believe as of today, NASA is the agency that is got the technology to lift the heaviest payload. And I believe that that rocket is unable to lift the amount of metal, lead, water, or blocking materials to completely shield a Mars crew on a trip to Mars. Interestingly, the Saturn V from the Apollo era space program is the rocket that still to this day holds the record for the largest payload capacity to low Earth orbit, or LEO. The payload capacity is 311,152 pounds, or 141,136 kilograms. The spacecraft Dragon Heavy, or Dragon 1, can carry 6,000 kilograms or 1,300 pounds, a minute amount of what the Saturn V of the Apollo era could have carried to low Earth orbit. Of course, it is said that a trip to Mars could expose astronauts 60 times more to radiation than they normally would, and they could be exposed to radiation levels as if they were exposed to up to 600 chest x-rays, which is pretty bad if you ask me. So radiation is definitely a problem we have not solved, and of course agencies and companies are working diligently to try to surmount that problem. The next issue that a deep space mission would have to face is the problem with different gravity fields. Not only lower gravity and no gravity, but also we would have to deal with changing gravity fields or gravity levels, such as the high G's or high gravity that astronauts experience as they blast off from Earth. It could be several Earth gravities, or G-forces as they call them, could be experienced by astronauts as they leave Earth, which is quite a traumatic event that the body needs to absorb. And also the body needs to get used to or accustomed to 0G as they arrive in space. The minute they arrive in space, they experience 0G, they begin to float and have a little fun. However, the body begins to suffer immediately after you start to feel 0G. Your organs begin to be shocked by the change and begin to try to adjust. Hopefully, if everything goes right, you will adjust eventually. It could take, I believe, from days to weeks, depending on the individual and many other factors. I would suppose age and many other genetic factors. Also, as you spend time in 0G, your body, of course, will begin to suffer biologically, physically, and also mentally, psychologically. You will begin to get weaker, older. You will begin to have adverse health effects in many, many ways. Your muscle mass will be lost to the tune of close to 2%, I believe. And bone mass also, bone density also is lost 2 percentage points per month as well. Of course, depending on the individual, depending on many factors. So it could be less, it could be more of the bone mass and muscle mass that you lose per month. Of course, this affects many other areas of your health, cardiovascular health, nervous system, digestion suffers, your circadian rhythm will take a shock, will suffer. You will have problems, most likely sleeping, resting. You're going to have problems with your vision, most likely in most cases. You will have problems with your defecation, urination, you name it. Zero gravity will affect damn near everything about a person while in space, because we're just not evolved to live in such conditions, such environment. We are acutely attuned to live on Earth's 1G field, that is one Earth gravity field.
9.8 meters per second squared.
That is the acceleration or the gravitational pull that you are accustomed to. Anything more than that or less than that will adversely affect your health. Of course, there are some plans and mitigation techniques and strategies that the space agencies and other companies are counting on to combat this. Anything apart from crew selection, depending or resorting entirely on genetics and the ability for a human to withstand and absorb the effects of radiation and how well they get used to it, accustomed to it. Anything apart from that are usually exercise regimes that are quite inconvenient and grueling to get used to adhere to. It is over 2 hours of continuous exercise, strenuous exercise every single day for you to mitigate some of the ill effects of low or no gravity, zero gravity. There are other techniques such as spinning devices to generate artificial gravity or centrifugal force gravity. But these contraptions and devices are quite brute and draconian at this moment. And apart from very large structures that create centrifugal force, such as spaceships designed to create centrifugal force in a large scale, anything outside of that is going to be quite sickening and traumatic on the body, causing vertigo, motion sickness, and perhaps other ailments. I personally would hate to be put in a spinning machine and be spun like if I'm in a dryer machine tumbling around, or a washing machine just spinning around. That would be pretty shitty and sickening and a traumatic and harsh experience, I would believe. The same goes with the exercise regime. 15 to 20 minutes is about as much as I can muster of exercise, and let alone it being every single day. So 2 hours and up is just unthinkable. So yes, those problems remain. They remain large problems, and the technology involved with large-scale artificial gravity generation is yet to be developed. Also, there are, to my knowledge, zero artificial gravity generating machines. That is just a solution that exists only in science fiction. It is pure fiction. These energy fields that generate gravity are just fiction at the moment. So the changing gravity fields are also a huge problem that the space agencies have not solved. Of course, as you go through the deep space regions in between the Earth and Mars, the human body will likely suffer and weaken to the point where, as they approach the, I believe, 1/3 Earth gravity of Mars, then they will have to get used to that gravity. and they may be too weak if mitigating techniques and technologies don't fully work during the trip to Mars. The astronauts will be too weak to take even Mars gravity, and they may not be able to perform any kind of work, any kind of exploration, any kind of movement, significant movements on the surface without significant help from perhaps robots, transportation systems, automation, perhaps suits that are robotic that could help them move around. I mean, anything short of that, the astronauts will likely be too weak to move around. And that is something we and space agencies have not solved. Likewise, as astronauts return to Earth, that is perhaps the biggest challenge, the worst of the problems, because they will already be weak on the way to Mars. They will be even weaker as they explore around Mars, and then they will have to endure the long trip back to Earth, which I believe is even longer than the trip to Mars. And they will have to endure not only the trip to Earth, but they will have to endure the gravity, the drastic increase in gravity from 1/3 gravity to 0 gravity on a long trip of multiple months. And then they're going to hit a very strong gravity field as they approach Earth. As they break through Earth's atmosphere, they will feel perhaps several Earth gravities. I mean, the shock will be too severe to even imagine what that would do to the astronaut's body at re-entry. Usually the experience is several G's. I mean, it is a done deal for astronauts if they experience several G's after coming out of 0 G for months, and survival is probably not even expected at that point. Not only that, but if and once they survive re-entry, punching through the atmosphere in a blaze of fire, they will have to survive Earth's 1G and once again get accustomed to Earth's 1G somehow after many months of exposure to the 0G and low gravity fields. So this problem again is immense. It's the second on the list for a reason. That is because it is the second most severe. Third on the list is the problem of isolation. As a layman, the way I see isolation is the separation, the incubation of human beings in a can, human beings put in a cage for weeks and weeks on end, months on end, perhaps several years. And of course, they will have to remain in a pressurized can, not only during the trip, not only during blast off from Earth and the long trip to Mars, for example, but also on their stay to Mars. They will have to remain in a can, in a enclosed facility, enclosed structure, most of the remainder of their stay on Mars. Mars is a extremely hostile environment. Only humans, with our current technology, we are only able to explore the surface of Mars for very short duration periods, bursts, depending on very high-tech equipment and spacesuits. Mars' atmosphere is cold, dusty, toxic, and much more lethal than that of the moon because of the lethality of the gases present on the surface of Mars. Of course, there are no gases, to my knowledge, on the moon, and we only need to protect from the vacuum of space. On the moon, there is no atmosphere on the moon. There is a thin atmosphere on Mars, however, but it is toxic, unfortunately, and I don't believe that we can get anything from it. As breathable air, there's nothing to extract from it, to my knowledge. Therefore, we have to take our own breathing air within our spacesuits or equipment, and of course that limits any kind of forays outside of any kind of structure on Mars itself, whether it's the ship itself as a temporary structure there, housing whatever astronauts dare to land on it. And of course, that is isolation. Isolation is the restriction of movement, being in small spaces. Our current propulsion systems are going to limit the size of any spacecraft. The weight, the luxury level of any spacecraft is going to be limited. The facilities and everything dealing with the spacecraft are going to necessarily be small and quite austere, therefore providing isolation and restriction. Of course, isolation and restriction affects the human body in many ways, especially psychologically, mentally, socially. You are isolated from loved ones, from friends and family back on Earth. Of course, you won't be able to take loved ones with you for the most part. There may be a couple or two on board, but mostly, even if that's the case, they will be away from other family and friends and people that they trust and know. That is isolation socially and culturally. Also, there will be isolation from everything dealing with Earth, isolation from your likes, your favorite activities, favorite foods, favorite everything. You will be isolated from Earth's environments. Waters, the water from Earth, you will be isolated from the earth and dirt. You will be isolated from, again, the foods and the many items that can only be supported from Earth, including pets, animals, sunlight, Earth's atmosphere, a blue sky, green grass, all of that you're going to miss dearly. This is reportedly by astronauts that have spent long periods in space. They miss all of these things. The smells, the sounds, the feel, the touch, these things are going to be utterly broken away from you, denied to you while you're on the trip, and that will affect you psychologically and also biologically. Being enclosed in a can, in a cage, of course, you will be exposed to germs, bacteria, not only from your companions, your fellow astronauts, but also within your body. Your body harnesses germs and bacteria. Many of them are neutral or even friendly to your body, but they may evolve in zero G very quickly to something that your body rejects, something that may harm your body. And this is a big problem for NASA and any other space agency or company that wishes to go on deep space missions. Another problem with isolation is the people that you will be isolated with. The people you will be sharing the small and austere spaces with will likely be a problem. These people, although you train with them, you become very good friends, close friends with them, and you may be very comfortable and close with them on Earth, with all of the comforts of Earth. These attitudes and situations and dynamics may quickly change while on the way to Mars, and while on Mars, and while on the trip back from Mars. For example, you will be in close quarters, close vicinity with these people. These people may become different people all of a sudden for various factors and reasons. They may change their attitudes on the way there, on their way back. They may change the way they view you, the way they treat you. They may change everything about themselves. I mean, the trip will change you, and there is no telling in which way people are going to change and what the power dynamics will be like, what the cooperation levels will remain like. I mean, there are many changing factors that are very unpredictable. People are very jealous, hostile at times, violent, belligerent, and very social individuals, yes, but they are also capable of hurting other people's feelings very quickly, being nasty, being all kinds of ways that may be hostile, and on Earth, many conflicts among the crew. So there may be problems that arise from many problems, issues that have originated here on Earth, such as hierarchy, power structures, religion, race, tensions, sexual attraction or sexual tensions. There may be problems of trust, problems of all kinds of ways dealing with the social life of the crew, and isolation can aggravate these problems. Very likely, many other problems may arise. Even the mission itself may be compromised and even fail because of these seemingly unsurmountable problems. So the human factor is a huge problem that has not been solved for human space flight to deep space, of course, to destinations beyond the moon. Isolation will also bring the lack of communication, lack of socialization. Not only communication with loved ones, but also there will be delayed and very lagged communication with the people that you trust back on Earth, with mission control, spacecraft control, the experts and scientists and technicians on Earth that could help you deal with any problems that may arise or any situation that may arise on the spacecraft, on the trip. You will have a very limited and lagging, delayed communication as you go farther and farther from Earth. And that is a problem also that is caused by isolation. And that leads to the next problem, which is the distance from Earth. Distance from Earth is an unchanging problem, a problem that is likely not to be able to be changed. Just, it's a problem that will add complexity to the mission, will add complexity to the systems that are used for the mission, will add cost, of course, with complexity, and will add also risk. The systems that are sent on missions very far away from Earth need to be magnitudes more reliable, more complex, or simple, depending on the system. It needs to be, again, more redundant. So there's going to be a lot more weights, a lot more of the systems, or multiple redundant systems need to be deployed, adding to the weight and complexity of the mission. Perhaps, just like Werner von Braun suggested, multiple ships, treks, multiple crews, and multiple spacecraft, which will add, again, safety and redundancy to the mission. And of course, this will only add to the problems that distance from Earth will bring. Of course, distance from Earth will also add to the problem of lagging communication or delayed communications. And these problems add to the issue of an autonomous mission, a mission able to make decisions on their own, systems perhaps that make decisions on their own, or automated systems perhaps aided and helped out by artificial intelligence. These systems are yet to be fully developed, and of course they need to be extremely and highly reliable, meaning that the right decisions will need to be consistently made by these systems and the crew. So a very high level of crew selection, very strict and demanding crew selection will have to take place on this mission to Mars or any other heavenly body beyond the moon. And lastly, I'd like to discuss the problem, the yet to be surmounted problem of hostile and enclosed environments. This problem is very similar to isolation in that hostile environments, of course, to me, they mean a problematic environment or climate, whether it be social or even physical climates within the spaceship, whether it's a biological threat to the crew, some sort of problem caused by radiation, caused by gravity or the lack thereof gravity, debilitating illnesses, syndromes. There could be illnesses that we don't understand or know about develop, of course, because of the low gravity and radiation combination of the two. And also there could be some psychological problems, some clinically undeveloped or uncharted, unknown psychological problems may develop. This is a brand new environment, brand new experience that most people or no one has ever gone through or experienced. So, of course, I believe there may be problems with the social interactions of the crew that may arise, most likely. And I believe this to be a hostile environment. Fights may break out, physical fights. There could be altercations. There could be even attempts at harming each other, harming themselves. There could be threats to people's health, lives, etc. There could be casualties while en route to heavenly bodies. And of course, what do you do in such situations? What do you do if a fist fight or worse arises? What do you do if there's a murder or a casualty of some sort, accidental or otherwise, or if there's a death because of illnesses, or if there's a spreading virus? I mean, these are all questions that need to be asked and solutions need to be developed for these and any conceivable problem that may arise. A solution, and very viable and reliable solution, must be in place. And of course, these have not been fully developed. Also, just like before, a hostile environment could be something biological, a biological threat, whether it's originating within the spacecraft and the astronauts themselves, or even perhaps some sort of biological life form that is encountered in space, whether it's at the destination or a life form that develops from the many and varied bacteria and viruses that we carry from Earth. These things may mutate to the point where they may appear alien to us all of a sudden, and they may harm us in unpredictable ways. So the problems are many, and they are just bunched up and categorized in these 5 main categories that NASA has put together for us. Again, radiation, gravity fields, isolation, distance from Earth, and closed and hostile environments. And that is it for now. Thanks for listening, and I hope to catch you in the next episode. Have a great day.
Thank you for listening to this podcast or watching this video. Please subscribe, like, and share so you can support this work and so I can reach more people like you. If you'd like to support this content further, please click on the links provided here. Thank you again. Have a great day.
Thank you.